Hello friends, this is a question number 28 of Pathfinder Newton laws of motion. What is the wording of this question? The question is saying two balls of equal volume and masses are m1 and m2. m2 is greater than m1, is connected with a thin light thread and dropped from certain height. Viscous drag of air on a ball depends on its velocity and buoyant force is equal to the weight of air displaced by the ball. When the balls acquire a uniform velocity after sufficient time from the instant they were dropped, what is the tensile force in the thread? Okay, I tell you one thing, this question is completely comes from the terminal velocity concept in fluid mechanics. So those students or friends or knows about the terminal velocity concept, they will very easily calculate. Okay, come in question. What is the question is saying? That question is saying there is a two balls, one is this, okay, and other one is this. These are the two balls. Masses are different, so of course if the masses are different, this is m1 mass and this is m2 mass. M2 is heavier, so it is coming down, and m1 is in a lighter. Okay, it is connected via string, so this is a string or thread like this, and we release, so m2 will come down and m1 will come up, but both are coming with a general velocity that is called uniform velocity v. Okay, at this instant if the velocity is constant, means all force acting on this system is balanced force. Okay, so let's check it, how many forces are acting one by one. So first of all, the tension is acting on the thread, okay, and the gravity is also pulling down, which is m1g in this direction and m2g in this direction. Now my dear friend, it is dipped in a air, so the force of buoyancy is also acting. So in this direction the force of buoyancy is acting. So let's assume this one is the force of buoyancy, which is, we know very well, it is the volume of object, because the whole object is dipped in air. So complete volume of object and density of the air and g. Is it clear? Similarly, on the lower block, here also force of buoyancy is acting, which is v rho g. My dear friend, one more forces is acting, that is called viscous force, and viscous force is directly proportional to velocity. In the question it is given, so we are going with this forces. So here the viscous force is acting, Fr, which is K, it is depends, so Kv, and here it is also acting, it is Fr, Fv, I can write Fr, here it is also Fr, so Fr is equal to Kv. My dear friends, now I tell clearly, if the V is constant, then all forces acting on the each object is balanced form. So now you can write simply, if I am talking about m1, so from m1 it is T plus m1g, from m1 T plus m1g is equal to Kv plus V rho g. My dear friend, if I am writing the equation from m2, so from m2 you can write, it is Kv plus T plus V rho g is equal to m2g. My dear friend, if we add both equations, then we can, if we subtract the both equation, then we will get the result. So if you subtract the both equations, this is equation number 1 and this is equation number 2. So we can say that from equation 1 and 2, we can write it is m1g plus T is equal to m2g minus T. On this basis, you can say that the 2T is equal to M1, M2 minus M1 times G. So T is equal to, it is 0.5 M2 minus M1 times G. So in my point of view, this is the tensile force acting on the thread. Thank you so much for watching this video. Your correct answer is D.